Hi everyone. Now we're starting to present our work on distributed t-test, which is a novel way to detect hardware Trojan through EM side channel. I'm Hanqiu Wang, and the other person is Shiying Ling. So there's already a decent amount of work on Trojan detection through EM side channel, but most of them require a golden model, which is a Trojan-free model. But our work proposes a golden model-free detection method, and we integrated with the developed automatic EM trace collection platform. The platform is shown below. So you can see the platform is a computer controlling the oscilloscope and a 3D printer on which an FPGA and the EM probe is attached. So the EM probe will collect the EM traces from the FPGA. So we implemented an 15 megahertz AES-128 encryption circuit on the FPGA, and we select 4 Trojan from TrustHub, which is a benchmark website. And you can see they have different functionalities, and the code level is also different. Some of them is gate level, some of them is register transfer level. And for the EM trace we collected, I want Mr. Lin to describe how we process the data and what is the data like.
Okay, the EM trace data we collected has 5 dimensions. In the dataset, the first dimensions refer to the 100 different points we took on the chip with horizontal and vertical space of about 2 millimeters. The third dimension refers to the EM trace data obtained with and without hardware children activity. The fourth dimension refers to the 250 different 32-byte plain text inputs, and the last dimension refers to the EM data in time domain. For the dataset where her t-test is applied, this formula shows that the smaller the standard deviation of the date and the larger mean difference of the date, the larger the t-score we get, which also indicates that the difference between the date and between the data of different groups is not due to randomness. Given the assumption that EM traces from either children activated or deactivated are different, we can detect hardware children if we get high enough t-test score.
So results are pretty good. We can see that from this plot is when the Trojan is active versus inactive. The t-test score is much higher than other scenarios. And if we plot the t-test score in a 10 by 10 grid, as I said before, then we can locate we can spot a brightest spot. There's a high likelihood that the Trojan is implemented at the brightest spot location. So the project is not over yet. We have some future work items. One is design an on-chip EM sensor, which eventually will replace the EM probe. Since the sensor is integrated in the package, it has much higher signal to noise ratio and can detect Trojan better. The other one is combining the EM simulation results with the measurement results. If we can use the simulation results as prediction and update the EM traces based on the measurement result, then we can deploy a Kalman filter and eventually in the runtime, because Kalman filter have relatively low overhead. That's it. Thank you.